if this is okay for you.
Yes, yeah. I'm going to time myself and I'm going to beat myself out after 10 minutes.
Wonderful. Thank you.
Oops. Okie doke. So hello everyone. Yeah, my name's Charlie, and I've got 5 confessions to make before starting this talk, or rather as part of this talk. The first is that I'm kind of a fraud in that I'm not a modeler. I'm not an integrated assessment modeler, but I am a social scientist who works a lot with modelers. And from this perspective, I've been sort of interested over the years in how you evaluate the modeling tools. The second confession is that this presentation is both very new. You can see here the paper that's just been published. If you look here, I don't know if you can see my cursor, published online 4th of May. That is today. This is the newest presentation you'll ever get. But at the same time, it's very old. This work actually began, believe it or not, 8 years ago at a workshop in a former EU project called Ampere that got me interested in model validation. The third confession is that this whole presentation is going to be one figure, but it's quite a complicated figure, and I'm going to build it up step by step by step. The fourth confession is that, well, it's not really a confession, that this talk is about specifically global integrated assessment models and how you evaluate them. And there may well be some interesting differences between that and how you think about national power planning models, like we've heard about from the previous stakeholders. And fifth and finally, my fifth confession is that most of this talk is about evaluation in general, but at the end, I will talk specifically about how you evaluate with respect to renewable energy deployment, which I know is the focus of your workshop. Okie doke. So, yeah, I mean, the first thing to say is kind of obvious that global integrated assessment models are increasingly influential on all sorts of things, but I don't think their fitness for purpose is visibly evaluated. And when I say visibly, I'm using as a reference point what happens in the climate modeling world, where each IPCC assessment round, there is a dedicated chapter on climate model evaluation. And there's a lot of very visible evaluation products of climate models, which I think are lacking in the integrated assessment world. And this is kind of interesting. This is actually what got me interested in evaluation as a topic. The second thing to make clear, and I think you all know this very well, is that integrated assessment models globally have become very sort of complex, sprawling beasts with all sorts of different biophysical and socioeconomic processes that they capture at everything up from national to regional to global scales. And increasingly now, we're asking them not just to tell us useful things about climate change mitigation, but to tell us useful things about, for example, meeting multiple sustainable development goals at different spatial scales in different sectors simultaneously, and so on. So the sort of application domains of these models has become broader and broader and broader. And they're used both in a scientific context and in a policy context, and that interface. And these multiple applications make evaluation more interesting, because part of evaluation is thinking about matching tool to task. But when your tool becomes very complex, the tasks similarly do. And by way, finally, the sort of introductory comment to make is that although you've been talking about model validation so far, for me, at any rate, for global integrated assessment models, where you have the modeled system is both open and uncertainly understood, you can't really validate the models. So you can't say pass or fail, right or wrong, accurate, inaccurate. You can say better, worse, and evaluation is really a process of trying to make models better and avoid them becoming worse. And my argument here goes back, I mean, there's a long literature around this, but really the sort of seminal work in this area, I think, for sort of complex natural human systems modeling was by Naomi Oreskes back in the 90s. And the paper in Science that's quoted there is a really great, short but pithy argument as to why you can't simply validate these complex models. Okie doke. So Detlev mentioned in his introductory remarks that he talked about evaluation criteria essentially as being legitimacy, credibility, and relevance. And in the paper we wrote, we slightly reframed that for various reasons. And we posed these 4 criteria against which you try and test or establish whether models are good enough for their intended use. So here they are on the right. You can see appropriateness. This is about matching tool with task. Have I got the right tool for a task? Interpretability is a sort of obvious one. I think earlier comments were made about the role of sensitivity analysis in doing this. Credibility and relevance, these bottom 2, are really where evaluation relies on involvement of user communities, whether they are either scientific or policy, in helping the modelers work on evaluation. So we have, if you like, on the left, what we're trying to do with evaluation. We have on the right the criteria against which we test how we're doing. And in the middle, we have our evaluation methods. So these 3, historical simulations, near-term observations, and stylized facts, are all methods which use observational data to test model performance, or in formal terms, to test the behavioral validity of models. So historical simulations, you tune certain parameters and then you see if the model can reproduce observed historical dynamics. Near-term observations is when you look back at model projections done, let's say 20 years ago, and you see how well they did against unfolding observations. And stylized facts are where you take sort of general phenomena which remain robust in the historical record and see if the models can reproduce those. All these behavioral validity tests are powerful, and I think it's what people most commonly think of when they think about model evaluation. But there are lots of problems with how they are applied to global integrated assessment models. One of which, for example, is that many global integrated assessment models are normative in that they they show cost optimal pathways, and yet we know that the real world doesn't, for all sorts of reasons, work on a cost optimal basis. So these methods all have strengths, but they also have limitations. Then these 3 other evaluation models at the bottom are ones which really take place sort of within the modeled world, if you like. So a hierarchy of models was mentioned earlier, actually, is in using the language of reduced form models or full form models. You can have very simple models which strip away all the sort of complexity to really test whether the core assumptions in the model, in how it represents the modeled world, are appropriate. Model-ins comparisons, I suspect you're all extremely familiar with, and sensitivity analysis has also been talked about. And this is useful, I think, as an evaluation technique for all sorts of reasons, not least because in identifying the parameters or assumptions to which your models are very sensitive, it also helps direct evaluation research in the real world to try and reduce those uncertainties so that better assumptions can be put in the models. So we have 6 evaluation methods overall and 4 evaluation criteria. And I'm not going to go through this in any detail, but there's not a simple one-to-one mapping of methods to criteria. So different methods will tell you things about particular criteria. So for example, historical simulations, if you find in historical simulations your model is actually very good at reproducing some observed dynamic, then that might give you confidence that the model is an appropriate tool for assessing that dynamic going forward in the future. So that's a match from historical simulations, one method, to appropriateness, one criterion. But there are many mappings of different methods to different criterion. And what that means is that if you're trying to put all this together, you have a series of methods, each of which has strengths and weaknesses or limitations. And you have this sort of non-one-to-one mapping of method to evaluation criteria. So what you really need is a multi-method approach to testing, learning, developing, and improving models against these various evaluation criteria, with the aim of ultimately establishing their usefulness for whatever task it is you want to use them for. And in the final 43 seconds, according to my watch, you can do this for renewable energy deployment. Okay, so don't freak out. There's a lot of extra information on this slide. What I've done is essentially switch some of the generic categories. All the text that's now become this kind of bluey green color is now specifically about global IAMs with respect to renewable energy deployment. So different studies that have been done that have established some part of the model as being better or worse for looking at renewable energy deployment going forward. And I put this up not to go through all of it in depth, but as a teaser and a taster for you to go and read our wonderful paper. Oops, there's my clock. A wonderful paper which came out today. Thank you very much.